We're now going to turn our attention to a key scheduler operator that's part of Project Reactor. This operator is part of the scheduler's utility class, and it's known as the parallel operator. This operator arranges to run other operators in the designated parallel thread pool. The scheduler's parallel operator hosts a fixed pool of single-threaded executor service-based worker threads. When you call this factory method, it returns a new scheduler that hosts this fixed pool of single-threaded executor service-based workers and is suitable for certain types of parallel processing. The size for this fixed size thread pool is obtained from a system property called reactor.schedulers.defaultpoolsize. And of course, you can set this property if you'd like. By default, it falls back to the number of processors, or more specifically, processor cores, that are available to the Java runtime during the initialization process. And this is what's available from the runtime available processors method that returns the number of cores. This particular thread pool is optimized for computationally intensive, non-blocking tasks due to the fact that it's fixed size and can't grow or shrink to handle blocking I/O. We'll talk about other operations that can be used, other schedulers that can be used for blocking I/O later. You can use this method in order to leverage the default parallel scheduler. So here's an example that we'll talk about later when we get to the case study, where we're going to go ahead and schedule all these different operations to multiply big fractions in a background thread that's part of the parallel thread pool. And you can see how we call subscribe on, passing in schedulers.parallel to provide the parallel context for this computationally intensive task to run. The implementation of the threads that are part of the parallel thread pool are done as so-called Daemon Threads. And this means that the app won't be prevented from exiting even if these threads are doing something, as long as all the other non-daemon threads have exited. So that's basically the definition of a daemon thread. It will shut down when all the other non-daemon threads shut down, or they will shut down since it's a pool of those daemon threads. The RxJava schedulers class provides a very similar capability in the form of its computation factory method. And this basically also returns a fixed size thread pool that's intended for compute-intensive and non-blocking tasks. So again, it's not intended for I/O-based tasks, but it's good for compute-intensive non-blocking tasks. For reasons that somewhat escape me, they ended up calling the methods different names in Project Reactor versus RxJava. But be aware that they have essentially the same semantics, even though the implementation may differ just a little bit. So that's the end of our latest discussion of advanced scheduler operators that are provided in Project Reactor.